Have you ever looked up at the night sky? Have you seen the pinpricks of light moving steadily across the darkness? Those are satellites. They are our creation. They are our eyes and ears in the void. They connect us. They guide us. They help us understand our world. But what if that peaceful view changed? What if the silent dance of satellites became a chaotic battleground? We often call space the final frontier. It represents our greatest hopes and our boundless curiosity. It's a place of discovery and cooperation. But we must also ask a difficult question. Could this final frontier become our final battlefield? The idea of war in space sounds like science fiction. It brings to mind images from movies with laser beams and exploding starships. The reality, however, would be very different. It would be quieter, colder, and in many ways more terrifying. Why would we ever fight a war in space? The reasons are not so different from the reasons we fight on Earth. It often comes down to three things: resources, power, and politics. Space is no longer just an empty void to be explored. It is becoming a place of strategic importance. Think of it as the ultimate high ground. From orbit, you can see everything. You can communicate with anyone, anywhere. Controlling space means controlling information. Then there are the resources. For now, this is more of a future concern, but it is a powerful one. The moon and asteroids are rich in valuable materials. There are rare earth metals essential for our electronics. There is water ice that can be turned into rocket fuel. Politics, of course, plays a huge role. Tensions on Earth can easily spill over into space. A conflict between two countries could escalate, with one side deciding to target the other's assets in orbit. Who would the players be in a potential space conflict? In the past, the answer was simple: the United States and the Soviet Union. The Cold War defined the early space race, but today, the landscape is much more crowded and complex. The number of countries with significant space capabilities has grown dramatically. China has emerged as a major space power with its own space station and ambitious lunar programs. Russia remains a key player, with decades of experience, a legacy of the Soviet era. India, Japan, and the European Space Agency all have advanced programs and independent launch capabilities. But it's not just about countries anymore. We are in a new era, the era of commercial space. Private companies are now major players in orbit. Companies like SpaceX, Blue Origin, and many others are not just launching satellites for governments. They are building their own vast constellations. This introduces a completely new dynamic. What happens if a conflict on Earth puts a company's assets at risk? A corporation's primary duty is to its shareholders, not necessarily to a single nation's foreign policy. The new great game in space will be played by a mix of powerful nations and influential corporations, each with their own goals and ambitions. What would the weapons of a space war actually look like? It is important to move past the cinematic ideas of dogfighting spaceships. The reality is far more subtle and technical. The weapons fall into several categories, some of which are already being developed and tested. The most straightforward are direct-descent anti-satellite weapons, or ASATs. These are essentially missiles launched from the ground, the air, or the sea. They travel into orbit and physically collide with a target satellite, destroying it through sheer kinetic force. Another category involves co-orbital weapons. These are sometimes called killer satellites. A country would launch a satellite that looks and behaves like any other. Once close, it could deploy a variety of weapons. It might use a robotic arm to grab and disable the target. It could release a small explosive charge. It might even use a net to capture it. Then there are the non-kinetic weapons, which can be just as devastating. These are the tools of electronic warfare. You don't need to physically destroy a satellite to make it useless. You can blind it by shining a powerful laser at its sensitive optics. You can jam its communications, preventing it from sending or receiving signals. The most advanced concepts involve directed energy weapons. These are the lasers and high-powered microwave weapons of science fiction, but they are becoming a reality. These weapons have the advantage of speed, as the beam travels at the speed of light. They also have the benefit of plausible deniability. The damage to a satellite from a laser might look like a malfunction caused by the harsh space environment. So what would happen if these weapons were ever used? Well, the first and most immediate consequence would be the loss of our satellites. You know, We often don't think about how deeply these orbiting machines are woven into the fabric of our daily lives. They really are the invisible infrastructure that makes our modern world possible. A war in space would mean the lights, in a sense, would start to go out. The first things to be targeted would likely be military satellites. This would blind armies on the ground, and it would disrupt their ability to communicate, to navigate, and to gather intelligence. A war on Earth would become much more chaotic and unpredictable without these assets. But the impact would quickly spread to civilian life. Think about the Global Positioning System, or GPS. We use it every day to navigate our cars, to track shipments, and even to find a nearby coffee shop. But GPS is also critical for so much more. It synchronizes financial transactions on the world's stock markets, helps manage power grids to prevent blackouts, and allows farmers to practice precision agriculture. Communication would be another major casualty. A large portion of our global communications relies on satellites. This includes everything from international phone calls and television broadcasts to internet access in remote areas. Emergency responders coordinating relief efforts after a natural disaster might lose their primary means of communication. The world would suddenly feel much larger and more disconnected. And what about our ability to understand our own planet? We rely on Earth observation satellites to monitor the weather, track hurricanes, and study the effects of climate change. These satellites give us the data we need to predict storms, manage water resources, and monitor wildfires. They are, in a way, our planetary health monitors. Amidst all this talk of conflict, there is one shining example of peace in space: the International Space Station. For over 2 decades, it has been a home away from home for astronauts and cosmonauts from many different countries. It is a project built on cooperation, particularly between the United States and Russia. These two nations, once rivals in the space race, learned to work together. The ISS is a partnership. Its operation depends on constant collaboration between control centers in Houston and Moscow. The Russian segment provides the propulsion that keeps the station in orbit, periodically boosting it to overcome atmospheric drag. The American segment provides most of the electrical power through its large solar arrays. The two are interdependent. One cannot function without the other. If relations on the ground were to break down completely, this partnership could shatter. The station could become a political hostage, a pawn in a larger conflict. The astronauts on board would be in an impossible position. Imagine being up there, floating in a tin can, completely reliant on people on the ground who are now enemies. Your crewmates, people you have trained with for years and trust with your life, are suddenly from an enemy nation. The worst-case scenario would be the abandonment or even the destruction of the station. This would be a tragedy on multiple levels. It would mean the loss of a unique scientific platform worth over $100 billion. The ISS shows us a better way. It proves that we can build complex, life-critical systems together. To see it torn apart by conflict on Earth would be a heartbreaking step backward for humanity. When we think about the damage from a space war, we might imagine clean, precise strikes. One satellite is eliminated, and that's the end of it. But the reality is far messier. When you destroy a satellite with a missile or another physical impact, it doesn't just vanish. It shatters. It explodes into thousands of pieces of debris. These pieces, ranging in size from a paint fleck to a school bus, don't just fall back to Earth. They stay in orbit, traveling at incredible speeds, over 17,000 miles per hour. At that velocity, even a tiny object carries enormous kinetic energy. A piece of metal the size of a marble can hit with the force of a bowling ball dropped from a skyscraper. This cloud of shrapnel becomes a permanent hazard. Each piece of debris becomes a bullet, randomly flying through the most useful and crowded orbits. In 2007, China conducted an ASAT test that destroyed one of its old weather satellites. That single event created over 3,000 pieces of trackable debris, and likely hundreds of thousands of smaller, untrackable pieces. Years later, the International Space Station has had to perform maneuvers to dodge debris from that very test. A full-scale space war would be exponentially worse. If dozens or hundreds of satellites were destroyed, it would create a massive, dense cloud of junk in orbit around our planet. This would make operating any satellite incredibly risky. the chance of a catastrophic collision would skyrocket. The very orbits we rely on would become unusable minefields. There is a theoretical tipping point for space debris, a nightmare scenario known as the Kessler syndrome. It was proposed by NASA scientist Donald J. Kessler in 1978. The idea is simple but terrifying. As the density of objects in orbit increases, the probability of collisions also increases. When two objects collide, they create more debris. This new debris then increases the chance of further collisions, which in turn create even more debris. Past a certain point, this process could become a chain reaction. It would be a cascade of collisions, each one triggering the next, until low Earth orbit is filled with a fast-moving, impenetrable shell of shrapnel. If a Kessler cascade were to occur, it would effectively seal us off from space for generations. Launching new satellites would become almost impossible. Any new rocket or spacecraft sent up would have a very high chance of being shredded by the existing debris field. We would be trapped on our own planet, imprisoned by a cage of our own making. It would be the ultimate act of self-sabotage on a species-wide scale. The frightening thing is that a space war could be the trigger for just such an event. The deliberate destruction of hundreds of satellites in a short period of time could inject enough debris into orbit to kickstart this chain reaction. It would be an irreversible catastrophe. There is currently no practical technology for cleaning up large quantities of small debris from orbit. Once the cascade starts, we would have no way to stop it. So, what can we do? How do we prevent this bleak future from becoming a reality? The answer, as it so often is, lies in communication and cooperation. We need to work together to establish clear rules of the road for space. We have treaties that govern Antarctica and the high seas. We need similar, robust, and verifiable treaties for the domain of space. One important step would be to ban the testing of destructive anti-satellite weapons. These tests are the primary source of long-lasting dangerous space debris. We also need to develop better systems for space traffic management. Just like air traffic control on Earth, we need a system that can track objects in orbit, predict potential collisions, and share that information openly. We should also lean into the things that unite us in space. International scientific projects, like the International Space Station or future missions to the Moon and Mars, are powerful tools for peace. When scientists and engineers from different countries work together on a complex problem, they build relationships. They build trust. They create a shared sense of purpose that transcends national politics. Ultimately, our future in space will be what we choose to make it. We can treat it as another arena for our earthly rivalries, a place to project power and fear. Or we can see it for what it is, the common heritage of all humankind. Looking down on the Earth from orbit, I never felt like a citizen of one country. I felt like a citizen of a planet. That is the perspective that space gives us. It is a perspective we must hold on to. We must choose to be guardians of this final frontier, not its warriors. We must choose cooperation over conflict, hope over fear, and a shared future among the stars. Final pause, letting the message resonate.